Okay, we're going to set up an experiment that will test this claim. So we've got to be really detailed in our in what we're going to do. Okay, so first of all, we don't want to just pick 2 tomato plants. We should have a big enough group that we think we'll be able to distinguish the effects. So maybe my units might be maybe 50 tomato plants. Now, if you're doing this, like, do you want to go get all your tomato plants at Pick and Shovel or your tomato plants at Agway? Or do you want to randomly get them from various stores all around town? Do you want to do a specific type of tomato plant? Those can be things that would increase your control if you are doing just a very specific type of tomato plant. But of course, your results will only apply to that very specific type of tomato plant. So um, okay, so like what sample frame did you use? Did you go get them from Pick and Shovel or from Agway or what like that? Okay, so anyway, we've decided we're going to use 50 tomato plants. Decide what kind of experimental design are you going to do? Completely randomized, randomized block, or matched pairs. Doesn't really make sense to do matched pairs. You can't really grow the tomatoes, then like start the same plant over again and not grow the tomatoes. I would say we have our 50 tomato plants. Let's then do a completely randomized design, assign them to their fertilizers like that. Okay, so using 50 tomato plants, I will use a completely randomized design. So remember, the 50 tomato plants were selected in a sampling process, which we are not talking about in our experiment. We are now at the experimental design, so we are going to use experimental words. Okay. The plants will be labeled 1 to 50. I will use a random number generator to pick 25 numbers from 1 to 50. Remember, just like with sampling, you will have to repeat it twice. And are you going to use repeats or ignore repeats? I'm going to ignore repeats. Okay, then say what are these first 25 numbers going to do? I think I'll send them to the treatment group. These 25 selected numbers will correspond to the plant numbers which will get the fertilizer treatment. You could always say like this, you could flip the coin and decide if that first group is going to get a fertilizer or no fertilizer. Okay, we're trying to decide if we can have a half dose, if that'll be enough to improve them. So the first group is getting the full, I'm going to say full fertilizer treatment. The remaining 25 plants will get the half dose fertilizer treatment. Whoops, treatment. Treatm. Okay. Okay, so then like that is not enough right there, because now I got to say I've now sent them to their groups. I've now given them their explanatory variable or factor, because it's an experiment. I can use the word factor. But what's going to happen to them? I need to continue with the idea of my control. So I will control, all the plants will get the same amount of water, sunshine. The same water and sunshine. And then what are you going to do to evaluate these tomatoes as being large and juicy? The tomatoes will be weighed, and how about we'll just taste them for large and juicy, the results will be compared of the groups will be compared. Okay, so I wrote that bottom part in green because like that's what people sometimes forget to take it that one step further, where you've written what you're going to do, but then you haven't really said what's going to happen after you've just said this is a treatment, but like what are you going to do after that? Like, so the detail has to be there, that you that you labeled them, that you selected from that same number group. You need to say that what you're gonna do with that group. You need to say what the treatment is, what the placebo or the control group will have. And then you do need to go into the detail of how you're going to further control this, and that you will compare the results at the end. That's very important. So that gives you a model for it. And then on these next ones, I want to, not have to write out everything, just because that's for you to do from now on. But okay, so like I just want to like point out some things that can be a problem. Like, first of all, we had 50 plants in that first example. We have to get away from the idea that you have to have 25 in the treatment and 25 in the control. I did a random number generator, and then that gave me groups that were of equal size, but that's not necessary for experimental design. You do not need to have equal groups. So I could have just as easily have taken my plants, and when I get to my first plant number 1, I flip a coin. Heads, you go to full dose. Tails, you go to half dose. Then I go to the next plant, flip the coin. As long as I am doing this, even if in the end I end up with 30 plants in one group and 20 in the other, it doesn't matter. It's a matter of being consistent. So here we have this example where we're assigning an SAT course to students. So I instruct them to come up to me one at a time, and I flip a coin. If the coin says heads, I'm going to send you to the online group. Tails, I'm sending you to the control group. In this thing, they said, well, once we get 50 kids assigned to one of the groups, then the remaining students will automatically be put in the other group. This is not a good way to do a design, because these remaining students, why didn't they come up? So what you're going to end up having is a whole bunch of kids potentially who have a similar characteristic. I'm not sure what that characteristic is, but they wouldn't come up first. So if you start a process like flipping a coin, then you need to recognize that group sizes do not need to be the same. You just have to be consistent in your method. So if you have your students and then you're going to random assign by flipping coin, then that needs to be consistent the whole time. And you're going to have your online group, and you're going to have your regular group. And we need to recognize these may not be the same size. And then, of course, at the end of it, you would compare the results. Now you would write all this in a narrative, like we did with the tomatoes. I just did a diagram so you can see the idea. But the idea being that if you're using flipping a coin, you were consistent and you followed it through all the way to the end. Like there was one example on an AP test where they had a butterfly experiment and they had a room full of like 100 butterflies, and they asked students to design an experiment with these butterflies. And you can say, like, I'll label the butterflies from 1 to 100. I will use a random number generator to pick numbers from 1 to 100. The first 50 numbers, ignoring repeats, will be the butterflies in my treatment group. The remaining butterflies will be in the other group. You can do that because I've said I've labeled all the butterflies. Now, in practicality, that would be incredibly hard to do, to label these little butterflies and to go out there and find butterfly number 20 and put them in the treatment group. But that would have gotten you 100% on the AP Stats exam. But in real life, probably a more practical thing would have been catch a butterfly, flip a coin, send it to the group. Catch the next butterfly, flip a coin, send it to its group. And then to not be hung up on the idea that they need to be the same sample size. Okay, so we won't write out everything. We'll just talk about what kind of words would pop out at me if I'm reading this. What kind of words would I expect to see in your writing? Okay, so first one, we've got women and men responding differently by advertising. Researchers would like to design an experiment to compare the effectiveness of 3 different advertisements for the same product. You have 300 volunteers. There's 180 men, 120 women. So, first of all, because they said that they think they respond differently, that's a characteristic. So when you're coming up with your design and you've already done your sampling, so they've already done their sampling of these things, I'm going to go to now the experimental words because I have my people, and I would say that this would be a randomized block design. Design. So that would be, you're going to rate your sentences. I would say things like, I will block by gender. Okay, block 1 could be men, block 2 could be women. I would use words like random number generator. I would have labeled the men from 1 to 180. I would have labeled the women from 1 to 120. I would have said that I will pick 90 numbers from 1 to 180, ignoring repeats. So I would expect to see in here ignoring repeats. Let's see, what other things would we do? And then, so then like once you had your block, men, and then you'd have block 1 could be men, block 2 could be women. Make sure you talk about the labeling. Then you're going to, it looks like you need 3 advertising groups. So you're going to have treatment 1, treatment 2, and treatment 3. And then you're going to have the same thing for women, treatment 1, treatment 2, treatment 3. Then you're going to be comparing, and and then you would compare the overall results. So vocab that I would see, you can call these treatments, or you could call them factors. The factor would be the type of advertisement. Of ad. Okay, anyway. All right, next one. Let's see what kind of vocab would we use for this next one. High school, they heard that this new SAT course is highly effective. They want to test whether this course is going to be better than their current classroom course. They have 100 students taking the SAT. I think this one sounds like I've just got 100 students. So I'm going to have my 100 students that have already been sampled. And I think we will use a completely randomized design. I guess the factor in this situation is going to be the online SAT course. You're going to be comparing them to the regular course. Probably when you're doing this, you're going to ignore repeats. When you're doing your random assignment, having labeled them from 1 to 100. Okay, what could you do to test a new detergent to see if it cleans better in warm or cold water? What could you do to test this? I mean, and I guess it depends. Like you could use completely randomized. Where you basically take your laundry, then you would, random assignment. And you could have random assignment to warm or cold. And then you could compare this. That would be a completely randomized design. Or maybe you could use a randomized block. Maybe you're going to block 1 could be your whites. Block 2 could be the colors, right? So design. You could use that kind of design. And it's not random into which block you go. I mean, if you're a white shirt, you go into block 1. If you're a colored shirt, you go into block 2. But then you have to have the randomness. You would randomly, randomly assign. I'm going to erase those lines. Okay, so randomly assign. Assign to warm or cold. This one, randomly assign to warm or cold. Okay, and then do your comparisons. Compare your results. And then just to say, you could actually probably even do a matched pairs here, which would be your highest level of control. So you might get a dirty item where you've controlled the dirt. Or let's see how this will say that we're going to add dirt to an item. To close. Each item randomly sent to either treatment 1, which could be warm, or treatment 2, which could be cold. Then you would have to make, add dirt to the items again. And then you would switch to the treatment that they haven't done, to other. And then once you've done that, then you compare your results. Compare for each item, each pair of pants or each shirt, and then you could see. And so that would be like the highest level of control, because you've now controlled it even for the type of actual clothing it is. Okay, and so when you get your results, what do they mean? So if you're taking if you're trying to see if a heart attack, if something is actually significant, and I'll just tell you that I did run a significance test on this. The probability of this happening, where if you have 21,996 male physicians randomly assigned to treatment groups that are receiving aspirin, and then you have a control group that's receiving a placebo, the probability of this actually happening, where by just chance variation, as chance variation, which you'll learn how to do this, but like the probability of this, the probability of, okay, anyway, the probability of this happening was 2.127 times 10 to the negative 7. But just so you know that. But even if, besides that, even without knowing that, knowing that there are 239 heart attacks, and then there's only 139 heart attacks. Well, actually, let's see, heart attacks with the placebo. Or wait, no, which one was the placebo? This one was the placebo. So there's a lot more. And this one was the aspirin. We can see that this is almost double. So that is significant, significant difference and not like, whoops, significant, not likely the result of chance variation. So that's looking, when you look at the actual numbers, that's when you can use ORD like significant. Okay, so that's experiments. Make sure you're very clear about not using sampling words when describing an experiment.